Hello everyone, we the student of Bajaj Institute of Technology are presenting a topic of electrical safety on behalf of you. Our topic of presentation is reliability centered maintenance guided by Professor Partha Sarthi Subadhi sir. Our team members are Pratik Madavi, Animesh Shende, Asta Navare, Shubhamkar Hiswankar, Shivam Sansure.
Hello everyone, I am Pratik Madavi from 3rd year electrical engineering and my topic is what is reliability centered maintenance and a brief history of RCM. Reliability centered maintenance is a corporate level maintenance strategy that is implemented to optimize the maintenance program of a company or a facility. The final result of an RCM program is the implementation of a specific maintenance strategy on each of the facility assets. The maintenance strategy are optimized so that the productivity of the plant is maintained using cost-effective maintenance techniques. Reliability-centered maintenance is the process of determining the most effective maintenance approach. The RCM philosophy employs preventive maintenance, predictive maintenance, real-time monitoring, run-to-failure (RTF), also called as reactive maintenance, and protective maintenance technique is an integrated manner to increase the probability that a machine or a component will function in the required manner over its design life cycle with a minimum maintenance. The goal of a philosophy is to provide the stated function of the facility with the required reliability and availability at the lowest cost. RCM requires that maintenance decision be based on maintenance required supported by sound technical and economical justification. Next is a brief history of RCM. RCM originated in the airline industry in 1960s. By the late 1950s, the cost of maintenance activities in this industry had become high enough to warrant a special investigation into the effectiveness of these activities. Accordingly, in 1960s, a task force was formed consisting of a representative of both the airlines and the Federal Aviation Administration to investigate the capabilities of a preventive maintenance. The establishment of the task force subsequently led to the development of a series of guidelines for airline and the aircraft manufacturers to use when established maintenance should for their aircraft. This led to the 747 Maintenance Steering Group's documents MHG-1 Handbook Maintenance Evaluation and Program Development for the Air Transport Association in 1968. MHG-1 was used to develop the maintenance program for the Boeing 747 aircraft. The first maintenance program to apply RCM concept MHG-2, the next revision was used to develop the maintenance program for the Lockheed L-1011 and the Douglas DC-10. The success of this program is demonstrated by comparing maintenance requirement of DC-8 aircraft maintenance using standard maintenance techniques and the DC-10 aircraft maintained using MHG-2 guidelines. The DC-8 aircraft has 339 items the required and overhaul versus only 7 items of an DC-10. Using another example, the original Boeing 747 requires 66,000 labor hours on major structural inspection before a major heavy inspection at 20,000 operating hours. In comparison, the DC-8 is smaller and less Cantered aircraft using standard maintenance program on the day required more than 4 million labor hours before reaching 20,000 operating hours. In 1974, the U.S. Department of Defense commissioned United Airlines to write a report on the process used in the civil aviation industry for the development of maintenance program for aircraft. The report written by Stan Nolan and Howard Heath and published in which all subsequent reliability-centered maintenance approaches have been based. What Noel and Heath found was that many types of failures could not be prevented no matter how intensive the maintenance activities were. Additionally, it was discovered that for many items for a probability of a failure did not increase with age. Consequently, a maintenance program based on age will have little if any effect on the failure rate. Now I request to Animesh Sande further proceed. Thank you.
RCM in the industrial and utility arena. As with many philosophy, there are many paths or processes that lead to find goal. This is especially true for RCM where the consequences of failure can vary dramatically. Rigorous RCM analysis has been used extensively by the aircraft, space, defense, and nuclear industries, where the functional failures have the potential to result in large losses of life, national security implications, and extreme environment impact. A rigorous RCM analysis is based on detailed FMEA, that is, failure mode and effect analysis. It includes the probabilities of failure and system reliability calculations. The analysis is used to determine appropriate maintenance tasks to address each of the identified failure modes and their consequences. While this process is appropriate for these industries, it is not necessarily the most practical or the best approach to use for industrial and utility system maintenance. For this system, a streamlined or inductive RCM analysis process may be more appropriate. This is due to high analysis cost of the rigorous approach, the relative low impact of failure of most industrial systems, the type of system and component maintained, and the amount of redundant system in place. The streamlined approach uses the same principle as the rigorous but recognizes that not all the failure mode will be analyzed. For the most industrial and utility system, the most economical and efficient approach is to use the combination of rigorous and inductive analysis depending on the system critically and failure impact. The failure mode that result in high cost of personal injury or where the resultant reliability is still unacceptable in terms of safety or operational impact still receives the rigorous approach, but all the other failure mode will be inductive analysis. RCM works for aircraft industry. Reliability Center Maintenance, that is RCM, was developed as an engineering process to optimize reliability and reduce the maintenance cost of commercial airliners. The sheer amount of data that is generated through millions of hours in flight time has allowed these aviation engineers to pinpoint the hot spot over the year, allowing them to design and improve the maintenance process. The RCM approach is the best known for its continued monitoring of equipment and analysis of the data to make adjustments and improvements to equipment and its maintenance program. The other industrial don't benefit from RCM in the same ways, especially if they are in firefighting mode.
My name is Astha Navre, roll number is 510, and my topic is the primary principles of RCM. Let's have a look on some of the principles. The first one is function oriented. RCM is a function oriented program that is focusing attention, function of system or equipment. RCM simply analyzes or evaluates functions and possible failures for selected asset. Rather than focusing on preserving assets, these analyzing helps one to focus on preserving systems functions. RCM seeks to preserve system or equipment function, not just operability for operability's sake. Redundancy of function through multiple pieces of equipment improves functional reliability but increases life cycle cost in terms of procurement and operating cost. The second one is system focused. RCM is system focused program, that is, it does not only focus on individual assets but rather focuses on overall system. RCM's main aim is to preserve overall system from failures that are most critical. Focusing on system, RCM maintains functionality of each part of system that will help to increase in production and customer satisfaction. RCM is more concerned with maintaining system function than with individual component function. Let's see the third principle, which is reliability centered. RCM is reliability centered. RCM's main target is to maintain system reliability, that is, to make it perform well consistently without any interruption and failure. It simply identifies assets of systems that are most critical and then focuses on their maintenance strategies to reduce system failure. This will help in increase of system or assets reliability as well as their availability. RCM treats failure statistics in an actuarial manner. The relationship between operating age and the failures experienced is important. RCM is not overly concerned with simple failure rate. It seeks to know the conditional probability of failure at specific ages, that is, the probability that failure will occur in each given operating age bracket. The next principle is knowledge design limitations. RCM is generally acknowledges and recognizes design limitations of system. It is better for one to identify and acknowledge design limitations than to have them pointed out by someone else, which will decrease quality because it seems like one appears to have ignored it. No matter how good maintenance is, one cannot cover and overcome poor design of system. RCM's objective is to maintain the inherent reliability of the equipment design, recognizing that changes in inherent reliability are the province of design rather than of maintenance. Maintenance can at best only achieve and maintain the level of reliability for equipment that was provided for by design. However, RCM recognizes that maintenance feedback can improve on the original design. In addition, RCM recognizes that a difference often exists between the perceived design life and the intrinsic or actual design life and addresses this through the age exploration. The next principle is safety, security, and economics. RCM is generally driven by safety, security, and economics. RCM is a process that is being driven to firstly preserve safety and then preserve economy because safety is main. Safety should be preserved at any cost. Thereafter, cost effectiveness becomes the criterion. The next one is unsatisfactory conditions. RCM generally defines any failure as unsatisfactory condition, that is, not satisfying or meeting one's demand. Failure is something that can either lead to a loss of function or loss of a quality which is not acceptable by anyone. It is considered to be high hazard. Therefore, it is defined as unsatisfactory condition which should be handled with care to remove it permanently. Therefore, failure may be either a loss of function or a loss of acceptable quality. The next one is logic tree to screen maintenance tasks. RCM generally takes help of logical tree to monitor all the maintenance tasks. This provides a consistent approach to the maintenance of all kinds of equipment. Now, let us have an in-depth look on the logic tree for maintenance task. So, the first question that must be looked is, will the failure have a direct and adverse effect on the environment or health or safety? If it has, then it will check that if there is any PTNI technology that can be approached to resolve this problem. If the PTNI technology is available, then it will develop and schedule PTNI tasks to monitor or train the condition. Once the PTNI task is scheduled, it will perform the task. But if it does not have any direct or indirect effect on the environment, health, or safety, so it will check for the next question, which is, will the failure have a direct and adverse effect on security? If it has, then again it will check that is there any effective PTNI technology or approach that can be used to resolve the problem. So if it is available, then it will develop and schedule the task and perform it accordingly. Then, if it does not have any direct or adverse effect on security, then it will check for next question, that is, will the failure have a direct and the adverse effect on the energy efficiency? If it has, then again it will check for the PTI technology and it will schedule the task and it will perform the task. If it does not have any adverse effect on the energy efficiency, it will check for the next question, which is, will the failure result in other economic losses or collateral damage? If yes, then again it will check for the PTNI technology or the approach and accordingly it will schedule the task and perform it. But what if there is no PTNI technology or approach available? So it will check for if there is any effective interval approach. If there is available, then it will develop and schedule the interval based task and perform it accordingly. If effective interval approach is also not available, then it will redesign the system or accept the risk. And if there is no failure result in other economic losses or the collateral damage, so it will run. The next principle is applicability and effectiveness. RCM is a process that simply ensures that systems continue to do as per user requirement. Only successful implementations of RCM will lead to cost effectiveness. RCM also addresses that what can be done is if selected maintenance task is not applicable and effective. Selected maintenance task must be capable of reducing probability of failure and be cost effective also. The task must address the failure mode and consider the failure mode characteristics. Now, RCM acknowledges three types of maintenance tasks. These three tasks are time directed, condition directed, and failure finding. That is one of several aspects of proactive maintenance. Time directed tasks are scheduled when appropriate. Condition directed tasks are performed when conditions indicate they are needed. Failure finding tasks detect hidden functions that have failed without giving evidence of pending failure. Additionally, performing no maintenance run to failure is a conscious decision and is acceptable for some equipment. The 10th and the last RCM principle is RCM is a living system. RCM gathers data from the results achieved and feeds this data back to improve design and future maintenance. These feedbacks are an important part of the proactive maintenance element of the RCM program.
Hello, good afternoon. My name is Shubhankar Iswankar and my topic for presentation is maintenance action in an RCM program. So as we all know, RCM, that is reliably centered maintenance, is the process of determining the most effective maintenance approach. The RCM goals are used to identify the most cost effective and applicable maintenance techniques to minimize the risk and impact of failure in faculty and utility equipment and system. In short, we can define RCM as it is an applicable maintenance which is used to reduce or minimize the risk or fatality rate which is which is occurred due to failure in an equipment or utility of an equipment or a particular system. This allows system and equipment functionality to be maintained in the most economical manner. Specific RCM objectives are stated by Nolan and Heap are as follows. The first one is to ensure the realization of the inherent safety and reliability levels of the equipment. What does it means? It means we must, or the user, or to be specific, the employee must be ensured to realize the safety procedures and the reliability levels of a particular equipment in a company. Second one is to restore the equipment to these inherent levels when the deterioration occurs. If any of the equipment undergoes any deterioration or fault, then the person or the employee must have the responsibility to restore the equipment to the inherent or the required levels by which the device to be operated, followed by to obtain the information necessary for design improvement of those items whose inherent reliability proves to be inadequate. And the last one is to accomplish these goals at a minimum total cost, which includes maintenance cost, support cost, and economic consequences of the operational failures. This these are the four. Then, if the four above mentioned points are to be considered and they used effectively, then there are the four outcomes which are the which are represent or undergoes as follows. First one is perform no maintenance. The perform no maintenance is mainly referred to as a reactive maintenance, repair, fix or fail, or run to fail, that is RTF type of maintenance. This type of maintenance assumes that failure is equally likely to occur in any part and that a failure is not detrimental to the operation. When this is the sole type of maintenance which is practiced high failure rates, then large parts inventories and excessive amount of overtime become a common factor. A purely run to fail maintenance, that is RTF maintenance, programs ignore many of the opportunities to influenced by the equipment survivability. Then the next point to be considered or to be obtained as an outcome from an RCM analysis is perform preventive maintenance, that is PM. PM consists of a regularly scheduled inspections, adjustments, cleanings and lubrication, and finally followed by replacement of components and equipment. So we can say that this factor is majorly plays a vital role in in the equipment in the equipment's lubrication, cleaning, and the other things which are to be monitored for the effective output or working of the particular electronic equipment or electrical equipment. Preventive maintenance, that is PM, is also referred to as a time driven or interval based maintenance. It is performed without regard to equipment condition. PM schedules inspections and maintenance at predefined intervals in an attempt to reduce equipment failures. However, as Nolan and Heap are discovered, a PM program can result in a significant increase in inspections and cost without any increase in the reliability. Then the further point is perform condition based maintenance, that is CBM. CBM consists of predictive maintenance, that is PDM, and real time monitoring. Predictive maintenance, that is PDM, primarily uses non instructive testing techniques to measure and train equipment's performance. Real time monitoring uses current performance data to assess the machinery condition. CBM, that is condition based maintenance, replaces the timed maintenance task with maintenance that is scheduled only when warranted by the equipment condition. Continuing analysis of the equipment condition data allows for planning and scheduling maintenance activities or repairs prior to the functional or catastrophic failures. And finally, redesign. What is redesign? When a failure of a system or piece of equipment is at an unacceptable risk and none of the above tasks can help to mitigate the failure, a redesign of the equipment or a system is an order. What does it mean? It means even if we follow all the above procedures and the things, then even if there is a fault or there is a problem in the system performance, then we have no other choice by redesigning or redevelopment of the particular instrument or the device. In most of the cases, adding redundancy eliminates the risk and adds very little to the overall maintenance costs. So as we discussed, these are the 4 points that are outcome of an RCM analysis. What we discuss? First one is perform no maintenance. Second one is perform preventive maintenance, that is PM. Third one is to perform condition based maintenance, that is CBM, which consists of predictive maintenance, PDM, and real time monitoring, and followed by the last, that is redesigning of the equipment. These 4 points of an RCM program are very much important and plays a vital role in the performance of our equipment. Since these all the above four are analysis outcomes and no one and each one of the component is very much important than the other. So we have to consider all the four aspects to be measured or monitored. Thank you.
Hello everyone, my name is Shivam. Now I will discuss the impact of RCM on a facilities of life cycle. Facilities of life cycle is divided into two broad stages. First one is acquisition. It includes the planning, design and construction. Second one is the operations. Okay. Then the RCM affects all the phases of the acquisition and operation stages to same degree. Decisions made early in the acquisition cycle profoundly affect the life cycle cost of facilities. Even though expenditure for the plant and the equipment may occur later during the acquisition process, their cost is committed at an early stages. As shown in figure of our planning include a conceptual design fix 2/3 of the facility's overall life cycle cost. As a RCM decisions are made later in a life cycle, it becomes more difficult to achieve the maximum possible benefits from the RCM program. Even though maintenance is a relatively small portion of overall life cycle cost, typically 3 to 5% of facility operating cost, RCM is still capable of introducing significant saving during the O&M phases of the facility life. Saving of 30 to 50% in an annual maintenance budget are obtained through the introduction of a balanced RCM program. Then last one is the conclusion. Let Overall conclusion is that the reliability center maintenance, that is the RCM, is the process of determining the most effective maintenance approach. RCM is the technique that pull together the information necessary to understand how a piece of equipment performs and what can be done to improve uptime while minimizing the cost and effort. As the airline industry shows 40 years ago, RCM can not only improve the reliability of system, it can significantly reduce the required maintenance. In today's competitive world, economy that translate into money saves both from reduced failure and reduced work. And a properly implemented RCM program will continue saving money year after year. Okay, so thank you.